lots of different scans and add them together. That's the real benefit of Fourier transform NMR from my perspective as a user at least. But it turns out that the increase in sensitivity is far from linear.
Actually, can I correct something?
Yeah, please do.
Okay, so the sensitivity is actually, just plain sensitivity is proportional to the number of scans.
Yes.
The noise is proportional to the square root of the number of scans.
That's right.
And what you're looking at is signal to noise, which is n over n squared, which gives you square root of n. Which is really only important when we get to cryoprobes, which we may not talk about, but that's the basis of how a cryoprobe works.
Yes. I should have put more detail. I like that. I'm going to add that for next time. Okay. So here's some graphical data that I pulled out of somewhere for some arbitrary signal. One scan, you get a kind of cruddy looking peak. 8 scans is better, but it's not 8 times better. Okay. Doubling from 8 to 16 scans, it's a little bit better in terms of signal to noise, but it's not really that much better if you're keeping the noise constant in this plot. Okay. Doubling it again, doubling it again, doubling it again, you can see the square root relationship. Yeah?
Why 128? This is the biggest scale we can try?
No, you can keep running as many scans as you have time for on your instrument, right? But each scan takes some time, okay? And you don't have an infinite amount of time on the instrument because other people also need to use the instrument. So for those of you who say, oh, I don't have enough material, I'm just going to run a really, really, really long carbon spectrum, it would be better to make more material.
At some point I'm going to cut you off because I need to do fills and other
Yeah,
things.
exactly, yeah. And other people need to use the instrument, and your supervisor's paying for time. That's the other take-home message here. So, so more scans helps, but it only helps up to a point.
Like, is our supervisors pay as per like scans? If I run overnight carbon, my supervisor pay more money like that, or
It's basically, it's on time.
because I have a lot of them to run. So.
It's based primarily on time, but there's some other considerations.
Okay.
And to confuse every other NMR group in North America, we run as a co-op.
Yeah.
Where we share the costs and...
Yeah. But more or less, yes. The longer time experiments cost more money. And they cost, we only have so many NMR instruments in our facility, so if you're using it up by running it all night long, that means that you can't run more samples, right? Okay, so based on everything that I've told you so far, you would think that all protons resonate at one frequency, 300 megahertz, and all carbons resonate at a second frequency, say 75.5 megahertz. Okay? If that were true, that would be useless as a spectroscopic technique. But it turns out that actually that's fairly close to the truth. Okay, so I want you to think about this. What is the window in hertz for a proton experiment or a carbon experiment? In other words, protons resonate at 300 million seconds to the minus 1, plus or minus what? Based on what you know, the window of a proton NMR. Carbons resonate at 75.5 million seconds to the minus 1, plus or minus how much in hertz, based on what you know about the window of a carbon NMR. Think about that for 5 minutes.